Right, now we're going to look at some lines and circles and what those are called and what those mean and what we can do with those. But as these usually start out, first we need to know what a circle is. So a circle, even though you've been looking at it since probably kindergarten or before, you may have never gotten a formal definition for it. So let's do that now. A circle is a locus of points. That just means a collection of points that are all equidistant, so they're the same distance away. And how about I scoot this over so you can actually see it? It's a locus of points equidistant from a center point. So this is all just a very fancy way of saying that if I take the center point of the circle and I pick a distance, let's say 1.5 inches, and I draw all the points that are 1.5 inches away from that. As I draw more and more, and eventually I'm going to have infinitely many points, they start to connect and form this curve that we think of as a circle. So a circle is just a collection of all those points that are the same distance away from a central point. And usually when we name circles, we name them based off of a central point. So I'll name this point C. So we would call this circle C. So the next thing we're going to look at is one of the key features for identifying a circle. Like if you're asked for properties of a circle, this is going to be usually the one that comes up, is if you draw a line from the center of the circle to the edge of the circle, and we'll give this a letter so that it has a name. Segment CD is what we call a radius. So a radius is a segment connecting the center of the circle to the outer edge. So again, it connects the center of the circle to the outer edge. And the neat thing about this is if I draw multiple radii, the plural of radius would be radii, every radius in this circle is going to be congruent. So if I knew the length of CD, if I take any other radius in this triangle, it's going to be exactly the same. Now there's another idea, and this is connected to the radius, but different enough that it gets its own name. What if I draw a radius from there to there, and then in exactly the other direction, another radius, such that it looks like this? And I'll connect these, or not connect, but label them rather. Segment AB is what we call a diameter. And a diameter is just a segment that connects 2 points on the circle itself through the center. So it's a segment that connects points on the circle. Again, I should probably make this where you can read it, connecting points on the circle through the center of the circle. And it's very important that this does pass through the center. If it doesn't pass through the center of the circle, it is not a diameter. So there we go. 2 lines we've learned about so far, a radius and a diameter. And this is kind of the easy basic stuff. You probably, I hope, already knew all of this. So what we're going to do now is we're going to start looking at some of the lines you might be less familiar with. So I'm going to draw myself another circle here. Easier said than done. And I'm going to call this circle T, because frankly, who's going to stop me? And we're going to look now at a type of line that passes through a point outside the circle. So I'm going to have this point, and I will call this point S. And so what I'm going to do now is I'm going to draw a line through S that just barely touches the circle, so that it looks like this. And now, if that was drawn perfectly, obviously I'm not perfect and never shall be, But this just touches right there. We'll call this point R. And this line, by design, so I'm telling you what it's supposed to do, passes through S and R is a point on the circle. And this line does not go inside the circle. It just brushes the outside of the circle at R. So R is the only place where it touches this. And this means that SR is what we call a tangent. And let's get a definition for that. A tangent, a line that intersects a circle. So intersect just means touches. Intersects a circle in one place. So it only touches in that one place. It only touches at R, and it turns out that we have a name for that point where it touches. We call this the point of tangency. So there we have line SR is a tangent line to circle T because it touches it in only one place, and that would be R, which is our point of tangency. So now what we have to look at are a couple theorems about tangent lines that will come in handy to us later. So the first is this. Suppose I have tangent line SR, and I'm going to draw a radius that touches the circle at R. If I do this, and R is the point of tangency for this tangent line, and I've drawn a radius to that, what will always happen is that those two will be perpendicular to each other. They will meet at a right angle. So if you have a tangent line, it will be perpendicular. And that symbol right there means perpendicular to a radius drawn to the point of tangency. And again, all that means is that if I have a tangent line and I draw a radius to where that tangent line touches the circle, the radius and the tangent line will be perpendicular. And this does some nice things for us. We've just recently learned right triangle trigonometry, so if I were to connect S and T, now I could use all those trigonometric ratios to solve this. I can also use the Pythagorean theorem. If I were to connect S and T and make a triangle, we would know that a squared plus b squared equals c squared. So all kinds of things come into play now that we know that. Now there's another point about tangent lines that we need to be aware of. And so I'm going to draw another tangent line through S, just like that. We'll call this one Q. And what this tells me is an interesting thing about SR and SQ. So I'll just go ahead and write this out. If we have two segments of tangent lines that pass through the same external point, an external point just means a point outside the circle, the same external point. So two segments, we have SR, SQ. They're tangent lines, and we're looking at the point where they pass through, both of them pass through S to their point of tangency. They pass through the same external point, will be congruent. And the way I wrote that there is pretty funky, but if you get the idea, that's the more important thing, is that SR and SQ, because they're two tangent lines that pass through the same external point, they intersect outside of the circle, that tells us that segment SR will be congruent to segment SQ. And this also gives us some problem solving ability.